Good day. So today we're going to look at solving simultaneous equations. So simultaneous definition is important. Simultaneous means at the same time. So at some point, because we have simultaneous equations, we have to use both equations at the same time. That's what the word means. So we have two equations now, and because we have two equations, we have two unknowns. All the time we were solving for one unknown, we didn't know what x was, and we would have solved x. Now we have two unknowns, and because we have two unknowns, we need two equations to solve it. In higher levels of maths, if you had three things you don't know, you need three equations to solve it. So the way to go about solving this is we need to have different methods to use to solve this. This is one of the more popular topics in maths. They actually have 4 different ways to solve it. The method we're going to look at first is elimination, which is the easiest method usually for section 1. They have substitution, which is normally for section 2. You could do it graphically by drawing the graphs of these two and then seeing where they intersect. And one of the last topics you'll do at the end of the course will be solving using a matrix method. So the easiest way is elimination, and you'll see how elimination works now. So the goal is to make either the numbers in front, the x terms, or the y terms. Again, if I don't see a number, it's understood as 1. We want to make one of those pairs the same. So normally the x's be easier. The fancy word for in front of, by the way, is coefficient. So sometimes you might see they say coefficient of x, coefficient of y. So I'm going to pick x. So the numbers in front of the x, the coefficient x, I want to make them the same. And we're making them the same by finding the LCM. So the LCM of 3 and 2 is 6. So my goal now is to turn this into 6 and to turn this into 6. So to turn this into 6, I need to multiply it by 2. But since all of this belong together, that's the first equation, I have to treat all of them the same way. So all of them going to get that same treatment, even though I really want here alone to turn to 6. So 3 by 2 are going to get 6x. Everybody have to get the same treatment. 5 by 2, 10y. And 11 by 2, 22. So I'll multiply the whole equation by 2 again. The goal is to get 6x. Same thing in the second one. I want to turn this into 6x. So to turn that into 6x, I need to multiply by 3. And everybody in his row, in his equation, have to get the same exact treatment. So all of them going to multiply by 3. 2 by 3 are going to get 6x, which is what I want. 1 by 3 are going to get 3y. 5 by 3, 15. So far I didn't use both equations at the same time, which is what the definition of simultaneously means. Once I have both of them the same though, this is where I'm going to use both of them at the same time. So I'm going to do a long subtraction question here. Each piece, once both of them are the same, I'm going to subtract each piece from the piece on top. And now I'm going to subtract each similar piece. So 6 take away 6, 0. So this temporarily disappeared, or we get rid of it. That's why we call it the elimination method, because we temporarily getting rid of one of the terms. So again, that's why this is called the elimination method that we're doing at this point here. Work out the rest. 10 take away 3, I'm going to get 7y, and 22 take away 15, I'm going to get 7. Now once I have one unknown, I could solve for it, because this is easy to solve. We did like this before. I have 7y equals 7, or in other words, 7 things cost $7. How much for one of them? 7 divided by 7. So my answer for y going to be 1. So I'm halfway finished. The goal is to get the answer for x and for y. We find out that these y's are 1. So I could do back this whole same procedure and make these two the same and multiply this by 1, multiply this by 5, and get two new equations and do the same thing and get my answer. Or since I already know y is 1, I could use it. So since I know y is 1, I could sub this into any of the two original equations. And the nice thing here is you have the choice which one you want to do. So usually one might be simpler to use, and you can see the bottom one have smaller numbers, so that might be simpler to use, but you have the choice. Nothing wrong with doing the bottom or the top. So I'm going to sub y equal to 1, and I'll choose the second equation, 2x plus y equal 5. And I want to replace or substitute, we did substitution already, y with 1. So wherever I see y, I'm going to put 1. So this is really going to be 2x plus, and I'm replacing y or substituting y with 1. Equal to 5. And again, because I only have one unknown now, which is the x, this is easy to solve. We did like this before. I'll carry across the 5, the sign going to change, so I get in 2x is equal to 5 take away 1, 2x is equal to 4, so x going to equal to 2. So I'll find my two answers. X will be 2 for this one, and y will be 1. And if you want, you double check. So if x is 2, that means 3 by 2, 6, plus y is 1, 5 by 1, 6 add 5, it will work out to the 11. It worked for the top. Let me see if it's working for the bottom. X is 2, 2, 2 is 4, because I substituted now. Y is 1, 1 times 1, 1, 4 add 1, 5. So you know it's working. So just to show you it didn't matter which one we use, I'm going to do it with this one now, the first equation, just to show you it didn't matter. So what if I wanted to sub the y equal 1 that I get here? Remember, I choose the second equation. I could have choose the first equation, and if I'm going to use the first equation, again, the first equation is 3x plus 5y is equal to 11. So now we're going to replace y with 1. So wherever I see y, I'm going to put 1. So this is really going to be 3x plus 5 times 1, again, brackets mean multiply, and all of that equal to 11. And now I could work this out because you only have x. 5 times 1 is 5. So I have 3x plus 5 is equal to 11. All the letters on one side, all the numbers on one side. So I'll carry across this. I'm going to change the 11, take away 5. So I'm going to get 3x is equal to 11, take away 5 is 6. And you realize when I solve for x, I'm still going to get 2. It didn't matter which equation you use. It's a personal preference, which one you prefer.